Hello class, welcome to this video on the chapter 10 practice. So we're going to cover questions related to the chapter on circles. Let's go ahead and get started here. So the first couple of questions we have, find the length of the arc. So basically we're finding the arc length, so which is what we did in 10.1. So remember that when you're trying to find the arc length, we usually use S for the arc length. Now the arc length is related to the circumference of a circle. So remember that the circumference of a circle is the distance all the way around, and it's given by c is 2 pi times the radius. So if I want to travel part of the circumference, that will be the arc length. Okay, so the arc length is part of the circumference, and in order to figure out what part of the circumference I am traveling, I need to know the angle at which I traveled, the central angle, and I need to know the radius of the circle. Okay, the greater the radius, the greater the distance I travel. So I need to know those two things. The theta is to figure out what fraction of the circumference did I travel, half the circle or 3/4 of the circle, whatever. Remember that the circle is a total of 360, so that'll help us with that. Okay, so we need to figure out the fraction of the circle that I traveled, so theta over 360. So again, if theta is 180, then I traveled half the circle. So this is the fraction of the circle. And then I need the circumference of the circle, so I multiply that by the circumference, which is 2 pi r. So there's your formula for the arc length, and just and the motivation behind that formula. So we need the radius, which is given by 9 yards here, and we got the angle given by 75 degrees. So we can plug in to the arc length formula. We have 75 over 360 times 2 pi times the radius, which is 9 yards. All right, and then our final answer is going to be in yards because the radius is in yards. So we'll plug that in. And do the calculation here. So we got 75 out of 360, and I'll put that in parentheses. Times 18 pi. We get about 11.8. So rounded to the nearest tenth. So the S is approximately 11.8 in yards. All right, for number 2, we're going to do the same thing. So I'm not going to calculate the whole thing. I'm going to leave it to you guys to calculate it put it on the calculator. So I'll go just shy of the one step where you plug it into the calculator and get the number. All right, so we got S is equal to 300 over 360 times 2 pi times r, and the r is the radius, 11. And remember that the answer is going to be in feet. So I'll leave it to you guys to calculate that. All right, so number 3, find the area of each sector, round your answer to the nearest tenth. Again, for all of these, I'm not going to get the decimal. I'm just going to kind of show the work up until the last step here. So for finding the area, what's the motivation behind finding the area? Well, if you think about it, you need the area of a circle, right? And the area of the circle is given by pi r squared. So you need the radius of the circle, and you need the Greek letter pi. That's just a constant though, so you only really need the radius. So in order to find the area of the sector, however, I need to know how much of the circle I'm traveling. Am I traveling the entire pi r squared, the entire area, or part of it? So in order to do that, I need the theta, just like I needed the theta earlier here. Okay, so am I traveling half the circle, a quarter, whatever? That's given by theta. So for the same reason with the arc length, the area of the sector is still gonna need the theta over 360. Okay, and then we multiply that by pi r squared. All right, so for the test, I don't think I'm gonna give you anything in radians, so you don't have to worry too much about that. It should be in degrees. I'm not going to complicate it and put things in radians, but I did want you to know how to convert between degrees and radians during the lesson. However, we can just use this formula. It's given in degrees. We got 120 over 360 times pi r squared, and then r is 17, so 17 squared. Okay, I'll leave it to you guys to do the calculation there. Now the area of the sector here, we're still going to plug in the numbers here. We got 120 over 360 times pi r squared. And remember that the area is going to be given in inches squared. Since you're squaring the inches, you need to the area is going to be, the answer is going to be inches squared. Same thing here in inches squared. All right, for number 5, find the segment length indicated. Assume that lines which appear to be tangent are indeed tangent. So this line that appears to be tangent is actually tangent, which it crosses at that one point, so it's a tangent. And this here is a secant because it crosses at 2 points, right? So that's a secant line. The other one's a tangent. So in order to find the lengths of secants and tangents and so on, this doesn't really pertain to this particular problem, but we know that if we have a diameter or a radius and a tangent, that these are going to be 90 degrees. So it doesn't even matter that this is a secant line. What matters is that every time you have a diameter or a radius, it's always going to be perpendicular to the tangent line. So these guys are perpendicular, and therefore you have a right triangle. So we can call this x, and so basically we have the Pythagorean theorem here. A squared plus b squared equals c squared. So we have 12 squared plus 16 squared equals x squared. And then don't forget, when you get the numbers here, don't forget to take the square root at the very end. So we're going to take the square root of both sides. And so that's going to be x. X is going to be the square root of that. So I'll leave it to you guys to get the answer for that. All right, number 6, determine if line AB is tangent to the circle. Again, in order to determine if it's tangent, we need to prove that the Pythagorean theorem works. So essentially we're doing the converse of the Pythagorean theorem. So this is a radius, which means the radius has to be perpendicular. So we want to show that that's a perpendicular. In order to do that, we need to use Pythagorean theorem or the converse. So we got a squared plus b squared equals c squared. All right, so you're gonna do this on the calculator and see if this is true. Is this true? Is it true if you did that? And if that's true, then you're gonna say that it's tangent. And if it's not true, then that means it's not tangent, okay? So I'm gonna leave that to you guys to do that calculation and determine if that's a true statement or not. All right, number 7, solve for x. So assume that lines which appear to be tangent are tangent. All right, so we got tangent line here, and we don't know their values, but we know their expressions here. All right, so this is actually a theorem that states that this is the segments to a tangent theorem. I believe that's what it's called. And that states that if you have two tangents that kind of stick out like that, right, that they meet at a point outside the circle, then that must mean that the tangent segments themselves are congruent. So we're going to say that those are congruent based on that theorem. I believe that's called segments to a tangent theorem or something like that. So we have 5x minus 2 equals 3x plus 16, and then we can go ahead and solve for x here. Go ahead and subtract 3x on both sides. And we'll add 2 to both sides. Then we'll divide by 2 on both sides to get x. All right, so I'll leave that to you guys. Just finish that up. Find the measures of the arc or angle indicated. Assume that lines which appear tangent are tangent. So again, tangents here. We got two tangents. This time we're trying to find the angle, or we know the angle. We're trying to find the arc. Okay, so remember that this is a theorem that states that if you wanted to find the angle of two tangents on the outside or two secants or any combination of those on the outside, you take the difference of the intercepted arcs. Okay, so you're going to take the difference of this red intercepted arc and this purple intercepted arc, and you take the difference between those, divide that by 2. Okay, so the angle here is equal to, so this angle is equal to half the difference of this angle, which we'll call x, and if this is x, this has to be 360 minus x. So whatever this is going to be take away from 360 because they all add up, the purple and the red add up to 360. So we have here x minus, and then in parentheses, 360 minus x. And then you can solve this. So we have 65 equals half. Then you got double negative here, which turns that into a positive. So that's going to be 2x, and then minus 360. And then cut each of these in half. So you get half of 2 is 1, 1x, and then half of 360 is 180. Then we can add 180 to both sides to get x, and I'll leave that to you guys to get the final value of x there. All right, so for the number 9, assume that lines which appear tangent. So we got two tangents again, just like before. They appear to be tangents, so we'll assume they're tangents. And we know this angle, again, just like before, you take the difference of the intercepted arcs. That one minus that one. This time we know what it is in terms of x, 36x plus 3. So we got that 75-degree angle has to be equal to half the difference of the red arc, 36x plus 3. Now this time it's minus, and then this time since it's in terms of this, we have to do 360 minus that to get the purple. Okay, so the purple is 360 minus whatever that is. So we just got to be careful and just write it this way. And then we'll simplify that first, just so that we don't have to plug in all this mess in here. So we know 360 minus 3 is 357. So we got 357 minus 36x. So that's the purple part. And we can plug that in here now. All right, make sure we simplify and all that stuff here. So we got 75 equals 1/2. So we got 36x minus 36x, or minus negative 36x. Be careful, because you're double negative, so it's really plus. So it's 36x plus 36x, which is 72x. And then we got 3 minus 357, which is negative 354. And then cut each of these in half. So half of 72 is 36. And then we got half of 354. Let's see here. It's going to be well, it should be in the 100s. 170, should be about 177. And then we'll add this to both sides. So we have, this is going to add up to, that's 12, carry the 1. 252 equals 36x. And then divide by 36 on both sides. And I'll leave it to you guys to get that for x. And then that's what we were looking for, solve for x. All right, number 10, find the measure of the arc or angle indicated. Assume that lines which appear tangent, same thing. So we got a tangent line here. It appears to be tangent, so it is here, we assume. And we have some kind of secant segment there. So we have an angle between a tangent and some kind of chord or segment here, ignoring this line, of course. If you wanted to find that, well, you always need the intercepted arc. So there's only one intercepted arc here, and it's this one. And this behaves like an inscribed angle. So remember that an inscribed angle is an angle where the vertex is inside, it's on the circle itself, not inside, but on the circle. And you have the segments of the sides of the angle are inside the circle like this. They're chords, okay? The inscribed angle, if I wanted to get that inscribed angle, I need to know the arc, and it's half of the arc. So like if the intercepted arc for that would be all of this, right? If I knew that that was 100, then that means this is going to be 50. Okay, so that's an inscribed angle. It depends on that half relationship there. Now this is not an inscribed angle because the vertex is on the circle, right? But it only has one chord right here, this little part here that's inside the circle. This part is on the outside, that's a tangent. However, it behaves like an inscribed angle. All right, so it's still going to be follow that same relationship, and there's a theorem on that. Okay, so if I'm trying to find this arc, well, this angle is always going to be half of that arc. So in order to find that arc, I just got to double the angle. Okay, and that'll give me 110 degrees. So the other way to do this is the same way that we did these, right? With these problems, you always take the difference between the purple and the red, right? So in this case, there is no purple part here. It's only a red part. So you could use the formula here and say that 55 equals 1/2 of, and then you got the red minus the purple, but there is no purple. There is no part that is inside other than this red part, right? Normally you have a inside part on the outside and an inside part on, on the inside of the angle. This time you don't have such a thing. So it's actually going to be 0 for that. And therefore this goes away. And so then you can solve for x here by timesing by 2 on both sides and giving you the same thing here. Okay, so you get the same answer regardless of whether you use this formula or that other theorem. I forgot what the theorem number was. It might have been theorem 10-4 or something like that, but it's one of the early theorems we discussed. It's in lesson 4, 10.4 is when we went over that, inscribed angles, I believe. All right, so solve for x, assume that lines appear tangent arctangent. Okay, so with the same deal here, we got this and we only got one inside arc. So you could use the formula, or you could just say, okay, well, it's going to be, that double relationship or whatever. However, this time we got x here, 24x minus 6. So we got this arc here. Now, if I know that arc, I know this one right here. Okay, so this one right here is given by 360 minus that. Okay, so just be careful with that here. We're not going to double this. We're going to double 360 minus that, or half that rather. So let's figure out this red arc by simplifying this. So we got to do, so let's distribute the negative. 2 negatives is a positive right here. So we got this double negative here. So it's basically 360 plus 6. So it's going to be 366 minus 24x. Okay, so there's our red arc here. So now we can say that this is half that, or we could just double this to get that. Okay, so I'll use the formula just so that you can get used to it. 63 equals half of the red arc minus, there is no purple arc here, there is no arc here that's purple here, so we're going to leave it as 0, and so basically this goes away, and so you could just double it on the other side. Oh, I forgot, it's not going to be x, sorry, it's not going to be x, it's going to be this one here, because that's no longer x, it's all of that mess. And then minus 0. So we can get rid of the 0 and just focus on that. So let's half this on, let's cut that in half. So we got half of 366 is 1. See, I want to say it's 183. Yep, should be 183. We got 6, yep. And then minus half of 24. And then we can subtract 183 on both sides. And that'll give us negative 70 equals negative 12x. Oops, that's bad math there. This is not negative 70, it's negative 120. Okay, so that's negative 120, and then we'll divide by negative 12 there. And x is equal to, and then I'll leave that to you guys. Just kind of calculate that. It's not too hard to do. All right, and that'll give you x. All right, so number 12, find the measure of the arc or angle indicated. Assume that lines which be arctangent. All right, so we got a tangent line here, and we got a secant line here. All right, so in order to do this, if you have an angle on the outside, you take the difference of the, again, like we said earlier, the arcs, okay? So the intercepted arcs. So you got 2 intercepted arcs. You got one here, and you got one here, right? That's intercepted between those two. Okay, so you want to take the difference between those. And we know this is 188, so we can figure out this one. If we'll just call this x here. And so let's use the formula. So we know that the angle, 65 degrees here, has to equal half of the difference. So 188 minus x. And then we can, one thing that we could do is get rid of the half to begin with. So we can multiply by 2 on both sides to just kind of get rid of it. And then that way it goes away. And then 2 times 65 is 130 equals 188 minus x. Then we can subtract 188 on both sides. And I'll leave that to you guys to solve for x there. It's not very hard to do, but there's the hard work for it. Number 13, solve for x. Assume that lines, same deal, appear tangent are tangent. We don't have to prove that they're tangent. Same deal here. We got an angle here. We got an inside arc here. And we got an outside arc here, this time in terms of x. So we got here 45 is equal to half the difference between 15x minus 10 and 65. So we just got to do the math here. Let's multiply both sides by the 2 to get rid of that half. You get 90 equals, now you can do negative 10 minus 65 is negative 75. We can add 75 to both sides. We can divide by 15 on both sides there to get x. All right, so this one, we got chords on the inside, or you can think of them as secant segments because they touch 2 points. Either way, chords. In order to find chords, if you know this angle is going to be half the sum of, instead of the difference, it's going to be the sum of the intersected arcs here. The intersected arc for this one, and then the intersected arc for the angle on the other side, which is this one here. So it's going to be half the sum of those. All right, so we know that the angle has to equal the sum, half the sum rather, of the red intercepted arc and the purple one. There you go. So there's our equation. We'll solve it. Let's get rid of the half by times in it by 2. So we'll times each of these by 2. So that's going to be 22x plus 18. All right, so now we got 18x minus, then we got to do negative 2 plus 56, which is positive 54. Then we'll solve for x here, the usual stuff here, the usual algebra 1 stuff. We got 4x plus 18 equals 54. Subtract 18. And you get 36. Then we can divide by 4, and I'll leave that to you guys to solve for, finish off that x there. All right, so here we got an angle on the, so we got here, okay, so this is an inscribed angle. Okay, so if we have an inscribed angle, remember that inscribed angle is on the circle itself and it has chords as the sides. That's the case here. So you take the intercepted arc, right there, and you cut it in half. Or, like I said, you could think of it as like one of these problems, right? Number 13, where you can say that you have the red arc, but you do not have the purple arc, and you could say that the purple arc is equal to 0. Either way, it doesn't really matter. It's the same answer. So we know that this angle has to be half of the difference, if we were to think of it as a difference between that and the purple arc, but there is no purple arc on the inside. It's just, there's nothing there. So we can get rid of this, and this goes away. And then we'll times 2 on both sides to get rid of it, and then we'll times 2 here. We'll distribute. It's going to be 18x minus 20 equals 15x plus 10. And we can subtract 15x on both sides. Get 3x, bring down everything else. Then we'll add 20 to both sides. 3x is equal to 30, and I'll leave it to you guys to solve the rest of that. Okay, so number 16, we got another inscribed angle. So all we got to do is, we know that it has to be, that inscribed angle has to be half of that. So 70 has to be half of that red arc. And of course, the purple arc is just 0, so I'm going to ignore it, okay? So it's really minus 0, but there's nothing there. Let's times 2 on both sides to get rid of it. So you get 140 equals the red. And we'll subtract 5 on both sides. And I'll leave it to you guys to solve that. Finish that up. Number 17, find the measure of the arc or angle indicated. Same deal. We got an angle on the outside, so it's going to be half the difference. So the difference of the outer intercepted arc and the inner intercepted arc. Let's call the outer one x, and then the inner one's 45. So it's going to be half the difference of x and 45. So then we times 2 on both sides just to get rid of it. We get 110 equals x minus 45. I'll leave it to you guys to solve that. Not very difficult to do. All right, so number 18, solve for x. Same deal. Angle on the outside, 3x minus 2 equals half the difference of the outer intercepted arc and the inner. So you got 10x minus 5 minus 43. Times 2 on both sides. Remember to distribute. We get 6x minus 4 equals, then we got to do all of this. Minus 5 minus 43 is negative 48. We'll subtract 6x on both sides. Let's go ahead and add the 48 to the other side. Might as well do that. So we get 44 is equal to 4x. So I'll leave it to you guys to finish that up. Find the measure of the arc or angle indicated. This time we got an inscribed quadrilateral. So for the inscribed quadrilateral, you want to use corollary 3 of one of the theorems, the inscribed angles theorem. So, or inscribed angles, just use inscribed angles, essentially. That's what it is. Okay, so that's exactly what we're going to use. We're not even going to worry about corollary 3. Just focus on finding this angle. So now we know that, we'll call this angle x. We know that this is an inscribed angle, right? So first, let's call this y. Let's find this angle. This is also an inscribed angle here, right? So, and remember that the measure of an inscribed angle is always half the intercepted arc. So the intercepted arc for this black angle is this one right here. And we know that if we add those together, we get the entire red arc. So the entire red arc is 150. It's 80 plus 70, okay? All right, so that means that if that's 150, this angle has to be half of that, right? So this, we'll call it the black arc here, the black angle. So that angle has to be half of that red arc, which is going to be 75. So we know that's 75 degrees. Okay, now, and not that you really needed it because you're trying to find this, right? So this time we want to get this arc here. Now, in order to get this arc for this purple angle, I'll just call this, I'll call it the blue angle. I want to get that blue angle there, call that blue x. If I wanted to get that angle, I need to get this purple arc. In order to get this purple arc, well, I know that this red arc is 150, and so this purple arc must be 360 minus 150 because they add up to a full circle, which is 110 degrees. And then I can cut that in half to get x. So x is going to be half of the 110 degrees, which is 55 degrees. Oops, that's a bit too small. Sorry. It's going to be 210 degrees, not 110, 210. And so it's going to be should be 105. All right, there you go. That's your value for x, 105 degrees. Now, corollary 3 of the theorem states that the opposite angles here, x and y, must add up to 180. That's corollary 3 of the inscribed angle theorem. And so you can see that if I add those, I get 180. So that does check out. But the final answer we got is 105 there. All right, solve for x here, same deal. Well, actually, we're going to use inscribed angles here. So we know that this angle is 37. It's an inscribed angle. And so remember that the inscribed angle is always half of its intercepted arc. Okay, so that 37 is half of its intercepted arc. And the purple arc is really 0, so it's really minus 0 if you think about it from the other theorem. And we can either cut this in half or we can double that. I'm going to cut it in half this time because those are nice numbers. It's going to be 3x minus 5. And then we can add 5 to both sides. All right, and I'll leave it to you guys to solve that problem, to finish up that problem. All right, for number 21, we got another inscribed quadrilateral like number 19. And so it says, okay, so we're going to solve for x here. So let's see here. If we want to solve for x, we're going to have to use a 72 to our advantage. So in order to get that 72 is this arc right here. Okay, so in order to get that arc, well, I need the inscribed angle for that arc. The inscribed angle or something related to it, right? Okay, so let's use the information they give us. So they give us this 110 degrees, which is this angle from here to there, right? And so that means the intercepted arc for that, it runs from S to Q on this side. So that's the intercepted arc. And so the intercepted arc for an inscribed angle, the intercepted arc is always double the inscribed angle, or rather the angle is half of the intercepted arc, same deal. So we got to double 210 or 110 and get 220. All right, so there's my purple arc. Now this green angle here, which is between the, it's AQR, it runs between A and R. So the arc for that is from A to R, and I don't want to color over the colors I already have there, so I'll do it here below. So it's from A to R. So that arc in green is double 78, which is 156. So we know that that's 156 degrees. And if that's 156 degrees, if that's 156 degrees and this is that, well, I can figure out this angle in blue because they all add up to 360. So the green, or rather, let's see here. I know that the green, the blue, the red, and the purple add up to 360 here. So yeah, so I know that the blue, red, and the purple add up to 360, and therefore I can use that to my advantage. So we actually didn't need the green arc here. So let me erase the green arc. Sometimes you'll have information that you may or may not need, but here we could use this to our advantage. Blue plus red, and actually we did need the green arc, so I went ahead and redrew it here. We did need it because, and we did need it. We did need this angle. So we're going to use corollary 3. So because you don't know the blue arc and you don't know the red arc, so we can't really use the 360 trick here just yet. So what we're going to do is we know that if this is 78, then the angle on the opposite side, based off of corollary 3, is that angle on the opposite side is going to be 180 minus that, and that's from corollary 3. So that is going to be 102 degrees. Now, if that's 102 degrees, that means from the arc for that is from here to here, because that's where the angle ends up in both ends there, from A to R. And if that's 102 degrees, I can find the blue one now, because the blue one is this, it's double 102. So if I double 102, it's 204 for inscribed angles. And so 204 minus 136 will give me the blue. So the blue is 204 minus 136, which is, in this case, it's going to be 70, well, it's going to be 68. So there's my blue. Now that I know the blue, I can use the 360 trick right now. I can say the blue, red, and the purple add up to 360. So I'm going to use that to my advantage here. So the red plus the purple, purple's 220, plus the blue, which is now 68, adds up to 360. And I can use that to take advantage of that little fact. So I got 72x plus, and I add this together, 288. Subtract 288 on both sides. And let's see here. So it's going to be about 72 degrees, and then we can solve for x there. So I'll leave it to you guys to finish that up. And that takes care of finding x. Now, if they wanted you to find this arc here, then you just plug in that for x to get that arc. All right, so that finishes up that problem. Number 22, we have another type of corollary 3 problem. So we know that opposite angles have to add up to 180 based off of corollary 3. Okay, so let me color code these. I know that these are opposite angles and they must add up to 180 based off of corollary 3. And I also know that the purple ones, the opposite ones here, add up to 180. All right, so I'm going to clean this up a little. I know that 8 plus, I can subtract 8 on both sides. I can subtract 12 on both sides. I want to do that so that I can put all the numbers to the other side. I can add 6 and subtract 12 on both sides of the equal sign. So let's bring down the blue. We got 12x plus 8y is equal to 172 minus 12. It's 160. And we got, bring down the purple, we got 16x plus 8y equals 174 minus that, so 172. So we'll subtract this. We're going to subtract this because 8y minus 8y is 0. That's called elimination. This is how we eliminate a variable. If they have the same number, we can eliminate them that way. And we got 12x minus 16x is negative 4x. And then 160 minus 172 is negative 8. So you can solve for x there. X is going to be equal to 2. And then you can plug in. I'll leave it to you guys as an exercise to figure out what y is. To figure out y, you're going to plug this into either one of these equations. So we'll plug it in there. We got 12 times 2 plus 8y equals 160. And then I'll leave it to you guys to solve for y there and get the solution for both. All right, so we got 23 here. We're going to do this and do that. So we got 6x plus 18 plus 24y equals 180. Then we got 6x minus 2 plus 30y plus 2 equals 180. So again, let's subtract this 18 over. And let's add this 2. And oh, well, plus 2 and minus 2 cancels out. So they really go away already. So we don't have to worry about that. Okay, so we got, bring this down. 6x plus 24y equals 162. 180 minus 18. And then bring this down. 6x plus 30y equals 180. Oh, yeah. And then we can eliminate this by subtracting because 6x minus 6x is 0. 24 minus 30 is negative 6y. 162 minus 180 is negative 18 here. And then you can get y is 3. Okay, so now that we got y is 3, I'm going to leave it to you guys. Plug in to either one of these equations. Let's plug it into that one, for example. Plug that in for y, and then solve for x. Okay. All right, so finishing up here, we got a few questions here. Let's see, find the length of the segment, round your answer to the nearest tenth. So, all right, so here we're going to use some theorems related to chords and such. So we know that this is a chord, and this is also a chord. More specifically, it's a diameter, right? So we want to find this diameter. Now, for a chord, if you have, and this right here, this is a radius right here. So we know that a radius or a line that contains the center that cuts a chord at a 90-degree angle is also going to cut the chord in half. So the theorem states that if a radius or a line, a diameter or a radius cuts a chord at a 90-degree angle, then it must cut it in half. So if this is 11.5, then this is 11.5. All right, and we know what this radius, well, we know that this is the radius, right? So here, let's see here. So let's go ahead and solve for this, and then we'll double it and get the radius. So let's see what we get. Okay, and here I just realized that they weren't really supposed to give you that number there. So if they give you that number, then you can find the radius, and then you can double it. And then you won't have to do any of these problems. You won't have to work through what we're doing now. So let's assume that they don't give you that problem, and then or that number here. So let's go ahead and find this radius by doing the Pythagorean theorem here. So we got r squared plus 7.8, or rather, this is the hypotenuse, so the hypotenuse goes last. So we have a squared plus b squared equals c squared, and in this case c is r, that's the hypotenuse. And then we'll get r. Here, we'll do this real quick on the calculator. So 7 point, and then we got to take the square root on both sides to get r. So we got to do the square root of that entire sum. And if you do that, you get about 13.9, which would make sense if we knew that this was 6.1 and plus that would also give us 13.9, which is why you weren't supposed to be given that number. And then you can double that to get x. So x is double the radius. So it's going to be 27.8 approximately. Okay. So it's for number 25. Here we're trying to find this portion of the segment, and I believe this is also the radius here, I'm assuming, which again, they weren't supposed to give you this number here in the problem. You're supposed to be able to figure out the radius without that number. So we can find the radius here, and that number, that radius, is the same as this. So we can call this x as well. And this is the Pythagorean theorem here. So we got 6.3 squared plus 17.3 squared equals x squared. And so then we can take the square root and get the answer there. And I'll actually leave it to you guys to get that number. So you guys can get that number and figure out what x is by doing the square root of the sum there. All right, so number 26. We have here, we're trying to look for this portion of the segment here. Now we know that this is a right triangle here because that's 90 degrees, so this is 90 degrees. And we know that this here is the radius, which they give us the radius is 15.8. So this is 15.8. So we can use the Pythagorean theorem here. X squared plus 7.4 squared equals 15.8 squared. And then we'll go ahead and subtract this on both sides and take the square root to get x. So I'll leave that to you guys to get that solution for x. All right, for number 27, we got another right triangle scenario here. We got the diameter is 35.2, which means that this has to be half of that diameter. So we got to do, this is going to be half of 35.2. Half of 35.2 is, I believe, this would be 17.6, if I'm not mistaken. So we got that radius there. And we know what this is, I guess, because, so what we could do is we can call this y. So yeah, we can call this y. Now we know that if a chord gets cut in a 90-degree angle, it must get cut in half. So that if this is 16.3, then this is 16.3. So you can use the Pythagorean theorem to solve for y here. So we can get 17.6 squared, or rather, sorry, a squared plus b squared. So 16.3 squared plus y squared equals c squared, which is 17.6 squared. So you can solve for y by doing the square root of 17.6 squared minus 16.3 squared. If I subtract this over to the other side, that is. So then we can get y. And then once you get y, once you get this number, then you know what x is, because this entire thing is the radius. The radius is 17.6. So to get x, you do 17.6 minus y. So I'll leave it to you guys. Calculate y from here, and then you can subtract that from the radius to get x. All right, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So the measure of arc BCE. So we want to look for BCE. So we know that these are vertical angles. So if this is 45 degrees and this is 45 degrees. So we have two 45s, and then we need to figure out what this is. We know that this is a diameter. So if that's a diameter, then this has to be 180, right? So, or then that means all of this has to be 180, right? And so all we need to do to get this black arc is to take the red plus that black part. The red is 180. So that means we got the measure of this is 45, this 45 piece plus the 180 piece. And you guys can finish that up. 29, the measure of arc or angle SPQ. SPQ. So we want that angle, this angle here. So we know that this is 100 degrees, which means that this is 100 degrees. And they mentioned that these are the same length. These are the same angle measure. That's what these indicate. And so if I want to get SPQ, well, let's call this X. Let's call this X, right? Well, let's call these both X here, these angles. So these angles have to add up to 360 because it's a full circle. So we got X plus 100 equals 360. So I got 2X plus 100 equals 360, which means that 2X is equal to 260, and I'll leave that to you guys to finish that up to get x. All right, so for number 30. All right, so number 30, solve for x, assume that lines which appear tangent are tangent. So we got, this time we're looking for segments on the outside, not angles. So what we want to do is we want to use, so here's what we do. We take the product that has to be constant. So the product of the outside segment times the entire segment has to equal to the product of the outside segment of the on the other side, and times, and its entire segment. So it's outside times whole thing, outside times whole. Outer times whole equals outer times whole when you're talking about segments on the outside. So the outer part, 9, times the whole. Now the whole is x plus 9, right? The entire purple part is x plus 9. So we have that times x plus 9 equals outer times whole, 15 times another 15. All right, so there we go. So we can distribute that. 9 times 9 is 81. 15 times 5 is 225. I'll leave that to you guys to solve for x. 31. Now, when they're on the inside and they cross on the inside, well, this time you got to multiply either side. So the length on one side times the length on the other side. Length on one side times the length on the other side. So that's how you solve that. So we got 6 times 15 is equal to, and then we got x plus 3 times x plus 2. So the product must remain constant in these problems, and for this one is side times side. So 16 times, or 6 times 15, 15 times 6 here is going to be 90. And then you got to FOIL this. So we got x squared plus 2x, and then 3x times plus 6. That's foiling. And we got x squared plus 5x plus 6. This is a quadratic, so we got to solve this using quadratic methods. So what we want to do is set one side equal to 0. This is from towards the end, I guess, of Algebra 1 when you do quadratics. So this is going to be negative 84, and I need to factor this. So I need two numbers that multiply to negative 84, but add to 5. So in that case, let's do that on the calculator and see if we can find those two numbers. 84 divided by 2, so 42 and 2 do not make 5. 3 and 28 do not make 5. 4 and 21, not quite. 6 and 14, that makes 8, so we're getting closer. 7 and 12, that makes 5. One of them has to be negative, right? So we got negative 7 and 12. That gives us positive 5. So 0 is equal to, then you factor this, x minus 7, x plus 12. And then you say, okay, what makes this equal to 0? Well, when x is equal to 7, that makes that 0. What makes this equal to 0? When x is negative 12. Obviously, negative 12 does not make sense as a solution, so we pick 7. All right, so here, we're going to do the same thing. Red times purple equals red times purple. So we got x minus 4 times x plus 2. I'm not going to color code it anymore. We got 5 times 8, which is 40. So we FOIL x squared plus 2x minus 4x minus 8. And that's going to be negative 2x minus 8 equals 40. I'll show you guys the puzzle, and then I'll have you guys solve the rest of it. So we subtract 40 on both sides. And then we set up our puzzle. So we got negative 48 and then negative 2. So we got 6 times 8 is 48. One of them has to be negative. This one has to be negative because negative 8 plus 6 is negative 2. I'll leave it to you guys to solve the rest of that. All right, we got x times 2x plus 2 equals 7 times 12, which is 84. Distribute, we got 2x squared plus 2x equals 84. Let's divide both sides by 2, everything by 2, just to make it nicer. X squared plus x equals 42. Subtract 42 on both sides. All right, so we can factor that. We got negative 42 and positive 1, invisible 1 there, which is going to be 6 and 7. So it would be negative 6 and positive 7. So leave that to you guys to finish it up now that I've finished the puzzle there. And for 34, we have outer times whole. The whole thing is x minus 7 plus x minus 5, which that is equal to 2x minus 12. So we got to multiply that by 2x minus 12. So let me move this over. Is equal to outer times whole. So 4 times 6. 4 plus 2 is 6. So 4 times 6. Now 4 times 6 is 24. Let's distribute this. So we got 2x squared minus 12x minus 14x plus 84, 7 times 12, equals 4 times 6 is 24. All right, so we got 2x squared minus, let's combine this. That's minus 26x. Let's move this over to this side. So we get minus 60. Let's divide everything by 2 to get rid of that 2, because I don't like that 2 in front of x squared. So we get x, so divide everything by 2. X squared minus 13x minus 40 equals 0. And then we can factor. I'll show you that part, and then you solve the rest. So two numbers that multiply to negative 40 add up to negative 13. Let's see here. 8 times 5. Let's see. Okay, this should be a positive 60, not a negative, and this should be a positive 40. So this should be positive 40. Sorry about that. And so both of these have to be negative. Negative 8 plus times negative 5 is positive 40. Negative 8 plus negative 5 is 13, negative 13. So you can go ahead and solve, get that solution there. All right, so number 35. Whole, outside times whole equals outside times whole. The whole thing is 16, so you got to do 7 times 16. So this FOIL, x squared minus 6x minus 4x plus 24 equals 7 times 16. Let's do that real quick. 7 times 16 is 112. So then let's combine these like terms. And since it's quadratic, let's move this over to that side to make that 0. And so we got 112, negative 112 plus, I'll just do this right here so I won't make any mistakes, is negative 88. And then we see if we could factor it. So factors of negative 88, that add up to negative 10. That's going to be, let's see, let's do that. 88 divided by 8 is 11. 88 divided by 2, no. 88 divided by 4, 4 and 22, no, we can't get negative 10 from that. All right, so I just noticed a mistake. I forgot to add this together, and that's what happens. I went a little bit too fast there. So we got x minus 6 plus that. So I forgot to add those together. Remember, it's outer times whole, and I forgot to do the whole. So this is going to be 2x minus 10. So this should be 2x minus 10. So let's correct that and fix this part, and we'll finish up this problem. So we got 2x squared minus 10x minus 8x plus 40 equals 112. So we got 2x squared. This is going to be 18x this time. And we'll subtract 112. And we still got negative 88, so that won't change, I believe, right? So we got, oh, that's going to be 40. So we'll get that. It's going to be negative 72. Okay. Two x squared minus 18x. Okay, so then we'll divide this 2 off. And we get x squared minus 9x minus 36 And so this time it's going to be minus 36 and minus 9. So two numbers that for the 36. 36 divided by 4 is 9. 36 divided by 3, so it's going to be 3 and 12. And it's going to be negative 12 plus 3 is negative 9. So I'll leave it to you guys to finish that up. All right, guys, that was a long video. There's a lot of problems on there. Hopefully you guys learned a few things or reviewed a few things. And as usual, I'll see you in the next one.